Section 5.6a is about parallel lines. We'll start by demonstrating what parallel lines are and then some things that we can do with them. Our first equation, y equals 3x plus 2, you can see that the slope is 3. I'm going to write that as 3 over 1 because we need to use the rise over run idea. And the y-intercept is 2, also known as the point 0, 2. Now use that information, remember to graph this on the line. So I'm going to do that. I'll start at 0, 2, which is where my y-intercept is. And then I use my slope. Rise over run, so I'm going to go up 3 over 1. So there's my first line. The second line, y equals 3x minus 3. The slope also is 3 or 3 over 1. But the y-intercept is different. The y-intercept is negative 3, also known as the ordered pair 0, negative 3. So we start at the y-intercept, and we do the slope again, rise over run, rise of 3, up 3 over 1. And we have some room so we can do that again, up 3 over 1. And we draw a line to connect those dots. Now what do we notice? We notice that those lines are parallel. They never touch, and they go off forever and will never come in contact with each other. Now what causes that? The key is right here. It's the slopes. When the slopes are the same, the lines will be parallel. And that's the idea that we're going to use as we explore parallel lines. That leads us to our key concept for this section, is that two non-vertical lines that are parallel if they have the same slope. And that's really the key here. Parallel lines have the same slope. And you see some illustrations of that over here. Now we'll use that information to solve some problems. Here we're going to use the information we know about parallel lines to solve this problem. It says write the slope-intercept form of a line that's parallel to this line and that passes through this point. So we're looking for the slope-intercept form, which means we need the slope and the y-intercept. We're not given either of them. But what we are given is we're given an equation, and we know that our equation should be parallel to that. Well, in the last slide, we just learned that parallel lines have the same slope. So if you look at this one, the slope of this equation is negative 3. And since I want an equation that's parallel to that, that means my slope also needs to be negative 3. So we've just used this equation to find its slope and to find our slope because it's going to be parallel. We actually don't need this equation anymore. What we do need is this point, though. We can use this point and this slope to find the b, if you remember how to do that. You take the m and plug it in, and the x and y and plug it in there. So negative 2 goes in for the y, negative 3 for the m, and negative 1 for the x. And you remember this from a couple sections ago. We use this information to solve for b. Negative 3 times negative 1 is positive 3. And then I will subtract 3 from both sides. So negative 5 equals b. So there's my b. b is negative 5. My m is negative 3. I can now write my slope-intercept form of my equation. Now just to check, we know that my equation has to be parallel to this one. They both have the same slope of negative 3, so they are parallel. Here's another example to find the slope-intercept form that's parallel to this equation and passes through this point. Well, because it's parallel to this equation, I know that the slope of this equation is 1/2, and the slope of mine is parallel to that, so it also has to be 1/2. I now can use that slope with this x and y and plug it into the slope-intercept form to find the b. So y is negative 2, m is 1/2, x is 4, and I'll solve for the b. 2 goes into 4 twice, so this becomes negative 2 equals 2 plus b. I'll then subtract 2 to get the b alone, or isolate it. So my b is negative 4. I know now my m and my b, so I can plug that into the slope-intercept form. m is 1/2, and b is negative 4. One more thing to check, this equation is parallel to the equation that I was given because the slopes are the same.